Dear students, today let us study about derivatives of implicit functions. We already studied about finding the derivatives of explicit functions. F of y is equal to f of x is a explicit function. Explicit function. Then y is equal to 2x plus 3 or y is equal to sin 2x plus 3x square, etc. are the explicit functions. We already know about the finding the derivatives of these functions. Now we have to find the derivative of implicit functions. Here, explicit functions, dependent variable y expressed in terms of independent variable x, dependent variable y expressed in terms of x, in terms of independent variable x. Here y is the dependent variable, x is the independent variable. Here y is expressed in terms of x. Therefore, this function is called as explicit function. We already finding the derivative of these functions. We now implicit function. Implicit function is a function. Here, the dependent variable cannot be or does not express in terms of independent variable x. Yeah, dependent variable does not express in terms of independent variable. For example, x square plus xy is equal to 3 or sin y plus x is equal to 5. So, etc. These are the functions. We cannot express y in terms of x. We have to find the derivative of this type of functions. Implicit function is a function. Here, dependent variable does not express in terms of independent variable. Dependent variable y does not express in terms of independent variable x. Here, y x minus y is equal to 5. Example 1. X minus y is equal to 5. Here we can express this one by y also. Y is equal to 5 minus x. Y is equal to minus y is equal to 5 minus x. Then y is equal to x minus 5. We can express it here by finding dy by dx, differentiating with respect to x. Dy by dx is equal to derivative of x is 1, derivative of minus 5 is 0. Minus 5 is a constant, therefore derivative is 0. Then we can take this problem by x minus y is equal to 5, differentiating both sides by differentiating both sides with respect to x. With respect to x, here we get d by dx of x minus y is equal to d by dx of 5. Here d by dx of y is 1 minus d by dx of y with respect to x is minus dy by dx. Derivative of constant is 0. Therefore, dy by dx is equal to minus of dy by dx is equal to minus 1. Therefore, dy by dx is equal to 1. Here also we get the answer same. Here in this problem we can express the function y in terms of x also, dependent variable, but it expressed in terms of independent variable also. Y is equal to x minus 5. But in other case, we can't express this in terms of x. In that case, we differentiate the function with respect to x both sides to solve some type of that problems. Example 2. Y plus sin y plus sin y is equal to cos x. Is equal to cos x. Here we differentiating both sides with respect to x. With respect to x. Here d by dx of y plus sin y is equal to d by dx of cos x. Here, first derivative of y with respect to x is dy by dx plus derivative of sin y is cos y into derivative of y with respect to x. Therefore, dy by dx also we have to write, because cos y is differentiating with respect to y. Therefore, we again find the derivative of y also. Therefore, dy by dx we have to write here. Then is equal to d by dx of cos x. Derivative of cos x is minus sin x. Here x is the variable. We find the derivative with respect to x. Therefore, minus sin x. Then plus cos y is equal to minus sin x. Then dy by dx is equal to minus sin x divided by 1 plus cos y. 1 plus cos y. Here, finding the derivative of implicit functions, you have to differentiate both sides with respect to x, LHS and RHS also. Then find the derivative LHS side y plus sin y and RHS side cos x. Find the derivative of y. Here is dy by dx. Then sin y, derivative of sin y is cos y. Then again we have to write dy by dx also, because we find the derivative with respect to x. Then is equal to derivative of cos x is minus sin x. Then taking common dy by dx, we get 1 plus cos y is equal to minus sin x. Then getting the answer is dy by dx is equal to minus sin x divided by 1 plus cos y. It's the derivative of the implicit function y plus sin y is equal to cos x. Next, we take another problem. Third one, 2x plus 3y is equal to sin x. 2x plus 3y is equal to sin x. Here also, differentiate both sides with respect to x. You have to write this and that also. Then find the derivative with respect to x every term in the equation. Derivative of 2x. Derivative of 2x is 2 is constant. Derivative of x is 1. Therefore, 2 into 1 plus 3y. 3 is constant. Derivative of y is dy by dx is equal to sin x. Derivative of sin x is minus, here the derivative of sin x is cos x. Therefore, dy by dx, 3 into dy by dx equal to cos x minus 2. Then dy by dx equal to cos x minus 2 divided by 3 is the answer. Next, we have to find some more problem. Third one, we take some complicated problem here. Xy plus y square is equal to tan x plus 1. Tan x plus 1. Xy plus y square is equal to tan x plus 1. Here, differentiate both sides with respect to x. We get derivative of xy. Here, xy is uv rule. We use here uv rule because x into y, u into v. Therefore, x into dy by dx. Derivative of y, x constant. Derivative of y is dy by dx plus y is constant, derivative of x is 1 plus here two derivatives for xy because it's uv rule here use uv rule. U is x, v is y, therefore x into derivative of v is dy by dx, then plus y into derivative of x is 1 plus y square, derivative of y square is 2 into y. Y to the power 2 minus 1 is 1, 2y. Then again, derivative of y is dy by dx is equal to, then derivative of tan x. Derivative of tan x is sec square x or secant square x plus dy by dx. Yeah, x into dy by dx plus y plus 2y into dy by dx is equal to secant square x plus dy by dx. We take left hand side dy by dx, x into dy by dx plus 2y into dy by dx minus dy by dx, which is equal to secant square x minus y. Therefore, dy by dx is taken common here. X plus 2y minus 1. X plus 2y minus 1 is equal to secant square x minus y. Therefore, dy by dx is equal to secant square x minus y divided by x plus 2y minus y. Yeah, differentiate both sides. Here 4 terms are there. LHS side xy will differentiate xy with respect to uv using uv rule. Then y square is 2 into dy by dx, 2 into y to the power, y square is 2 into y to the power 2 minus 1 is 1, 2y into dy by dx with respect to x. Then is equal to derivative of tan x is secant square x plus derivative of y is dy by dx. Then taking dy by dx terms in the LHS side, we get dy by dx into x plus 2y minus 1 is equal to secant square x minus y. Then dy by dx we get secant square x minus y divided by x plus 2y minus 1. I think you understand these problems. All the steps also. First, you must familiar about the derivative of sin x, cos x, and x square x to the power n, etc. tan x, cosec x. Then only you find the derivative of the any functions easily. Next, fifth question. X square plus xy plus y square is equal to 100. Here, differentiate both sides with respect to x. With respect to x. X square is 2x plus here also xy. First put x as constant, then derivative of y is dy by dx plus y is constant, derivative of x is 1 plus derivative of y square is 2y into dy by dx is equal to derivative of any constant is equal to 0. Then here also we taking dy by dx terms inside x into dy by dx x plus 2y into dy by dx is equal to taking other terms in the RHS side minus 2x minus y. Therefore, dy by dx is equal to minus 2x minus y divided by x plus 2y. X plus 2y. Here we can write minus 2x plus y divided by x plus 2. X plus 2. Here it's the same problem like fourth one. X we have to find the derivative of x square is 2x, xy derivative of xy is x into dy by dx plus y plus derivative of y square is 2y into dy by dx. Then derivative of 100 is equal to 0. Then simplifying, finding the derivative of dy by function is dy by dx is equal to minus 2x plus y divided by x plus 2y. Next one more problem and we will do the sixth one. X cube plus x square y plus xy square plus y cube is equal to 81. X cube, x square y plus xy square plus y cube is equal to 81. Here, differentiate both sides with respect to x. 3 into x square plus here x square is constant, derivative of y is dy by dx plus y is constant, then derivative of x square is 2x plus x into derivative of y square is 2y into dy by dx plus y square into derivative of x is 1 plus y cube 3y square into dy by dx which is equal to derivative of 81 is equal to 0. Yeah, we have to find the derivative of x cube is 3x square, then x square y is x square into dy by dx plus y into 2x, derivative of x square is 2x. Then x square y is this, x into 2y into dy by dx plus y square into derivative of x is 1, then plus derivative of y cube is 3y square into dy by dx. Then we have to find the dy by dx by getting to together x square plus 2xy plus 3y square x square 2xy plus 3y square into dy by dx, which is equal to minus 3x square minus 2xy minus y square, minus 3x square minus 2xy minus y square, x square plus 2xy plus 3y square. Therefore, dy by dx is equal to, I am taking common minus sign, 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square is the answer. I think you can find the derivative of the implicit functions. So finding the derivative is the same type, but here it's not expressed in terms of dependent variable in terms of independent variable. Therefore, we have to find the derivative by differentiating both sides with respect to x. Now, we find the derivatives of trigonometric functions. Inverse trigonometric derivatives you know, but now we have to find the derivatives of inverse trigonometric functions. Inverse trigonometric functions. Derivatives of inverse trigonometric functions. Here, you know about the trigonometric functions. Derivative of sin x is cos x, or cos x is derivative of cos x is minus sin x, etc. But here we have to find the derivative of inverse trigonometric function. Let f of x is equal to sin inverse x. F of x equal to sin inverse x. Here derivative assuming derivative exists. Assuming it exists. Then we have to find the derivative of the function. Then sin y is equal to sin inverse x. Sin y is equal to x. Sin y is equal to x. Or x equal to sin. Here it's a implicit function. We have to find the derivative by differentiating both sides with respect to x. One derivative of x is 1, or d by dx of x is equal to d by dx of sin y. Here 1 is equal to derivative of sin y is cos y into dy by dx. Therefore, dy by dx is equal to 1 by cos 1. dy by dx is equal to 1 by cos 1. Here, cos y should not be equal to 0, which is equal to 1 by y is equal to sin inverse x. Therefore, cos of sin inverse x, sin inverse x. Cos y is not equal to 0. Then sin inverse x is not equal to minus pi by 2 or plus pi by 2, because sin inverse x equal to pi by 2, cos pi by 2 is 0, therefore it is not d pi. Therefore, sin inverse x is not equal to minus pi by 2 and pi by 2. Therefore, x is not equal to minus 1 to plus 1, equal to minus 1 to plus 1. Therefore, x is belongs to minus 1 to plus 1. Here it's open bracket. Minus 1 and plus 1 are not included here. X is not equal to minus 1 and plus 1. Then only defines. Therefore, dy by dx is equal to, defined in these terms, for x is belongs to minus 1 to plus 1, sin inverse x is equal to x. Then cos square y. We know about the cos square y is equal to 1 minus sin square y. 1 minus sin square y. Therefore, is equal to 1 minus sin y is equal to x. Therefore, it is equal to 1 minus x square. Therefore, cos y is equal to square root of 1 minus x square. Cos y is equal to 1 minus x square. Therefore, dy by dx from 1, we get dy by dx or d by dx of sin inverse x. D by dx of sin inverse x is equal to 1 by cos y is equal to, cos y is equal to root of 1 minus x square. Therefore, derivative of sin inverse x equal to 1 by square root of 1 minus x square. In the same way, we can find the other derivative as cos inverse x, tan inverse x, and cosec inverse x and sec inverse x also. Yeah, we have to take f of x is or function y is equal to f of x, which is equal to sin inverse x. Y is equal to sin inverse x, then sin y is equal to x. We express this as the implicit function. Find the derivative of the function by differentiating both sides. We get the derivative 1 is equal to cos y into dy by dx. Then dy by dx is equal to 1 by cos y. Cos y should not be equal to 0. Therefore, y is not equal to, y means sin inverse x is not equal to minus pi by 2 and plus pi by 2. Therefore, x is not equal to minus 1 and plus 1. Therefore, x belongs to minus 1 and 1. Open bracket. Minus 1 and plus 1 are not included here. Therefore, sin of sin inverse x equal to x, you know it. Then cos square y by identity, cos square y plus sin square y is equal to 1. By using identity, cos square y is equal to 1 minus sin square y. Therefore, is equal to 1 minus x square. Therefore, cos y is equal to root of 1 minus x square. Therefore, find the derivative of dy by dx of sin inverse x is equal to 1 by square root of 1 minus x square. Therefore, derivative of d by dx of sin inverse x is equal to 1 by square root of 1 minus x square. In the same way, we can find the derivative of cos inverse x also. Y is equal to cos inverse x. Here, x is equal to cos y, equal to cos y. Then derivative of this one is differentiating both sides with respect to x. We get 1 is equal to 1 by 1 is equal to minus sin y into dy by dx. Then dy by dx is equal to minus 1 by sin y. Minus 1 by sin y. Here also y is not equal to cos sin y is not equal to 0. Sin of cos inverse x. Here it is equal to minus 1 by sin of cos inverse x. Cos inverse x should not be equal to 0. It's minus 5 by 2. Sin of 0 is 0 and sin of pi also 0. Beyond these two, we can find the derivative of this function. Then 1 is equal to minus of dy by dx equal to minus 1 by sin y. Sin y also is equal to sin square y is equal to 1 minus cos square y here also. Therefore, 1 minus cos y is equal to x square. Therefore, sin y is equal to square root of 1 minus x square. Therefore, dy by dx is equal to minus 1 by square root of 1 minus x square. It's the same way, but here there is a minus sign because the derivative of the cos y is minus sin y. Therefore, the derivative of sin cos inverse x is derivative of cos inverse x is equal to minus of 1 by root of 1 minus x square. Same steps but different in the sign. Then you have to find the derivative of one more tan inverse x. Then other you have to find the other functions. Y is equal to tan inverse x. Third one, tan inverse x, which is equal to x equal to tan y. Here, x equal to tan y. Differentiating both sides with respect to x. 1 is equal to tan y. Derivative of tan y is secant square y into dy by dx. Then dy by dx is equal to 1 divided by secant square y. You know about the identity. 1 plus tan square x, 1 plus tan square y is equal to secant square y. Therefore, we can write 1 plus tan square y is equal to x square, which is equal to secant square y. Therefore, we can write here 1 by 1 plus x square. Therefore, derivative of dy by dx is equal to 1 by 1 plus x square is the answer. Yeah, we solved three inverse trigonometric, finding the derivative of three inverse trigonometric functions like sin inverse x, cos inverse x, and tan inverse x. Derivative of sin inverse x is 1 by square root of 1 minus x square root of 1 minus x square. Then derivative of cos inverse x is minus 1 by square root of 1 minus x square. Then derivative of tan inverse x is equal to 1 by 1 plus x square. I write down this all the formula. Inverse trigonometric functions and here derivatives. The derivatives. Yeah, sin inverse x derivative is derivative of sin inverse x is 1 by square root of 1 minus x square. Then sin cos inverse x is minus 1 by square root of 1 minus x square. Third one, tan inverse x is equal to 1 by 1 plus x square. Then fourth one, sec inverse x is 1 by x into square root of x square minus 1. X square minus 1. Then fifth one, cosec inverse x is 1 by x into square root of x square minus 1. Then sixth one, cot inverse. Derivative of cot inverse x is equal to 1 plus x square, which is equal to minus 8. 1 minus 1 plus x square, x into x square minus 1, 1 minus x square plus 1, 1 plus. Sin inverse x is 1 by square root of 1 minus x square, cos inverse x is, here is minus is given. Then tan inverse x is 1 by 1 plus x square, cot inverse x is minus. Sec inverse x is 1 by x into square root of x square minus 1. Then cosec inverse x is minus. Cosec inverse x is minus. Therefore, you have to find the, you know the steps to find the derivative of inverse trigonometric function. Then finding the or solving the problem, we can directly write the inverse functions derivative. Next, we solve some problems in the next class, implicit functions and inverse trigonometric functions. Thank you.